how far away are we from arriving at a theory of everything, do you think? And how important is it to try to arrive at it, at this kind of goal of this beautiful, simple theory that unlocks the very, fundamental basis of our nature as we know it? And, and what are the kinds of approaches we need to take to get there?
Yeah, so in physics, the biggest challenge is to unify quantum mechanics with gravity.
Mm-hmm.
And I believe that once we have experimental evidence for how this happens in nature, in systems that have quantum mechanical effects, but also gravity is important, then the theory will fall into our lap, okay? But the mistake that is made by the community right now is to come up with the right theory from scratch. And, Einstein gave the illusion that you can just sit in your office and understand nature, when he came up with his general theory of relativity. But, first of all, perhaps he was lucky, but it's not a rule. The rule is that you need evidence to guide you, especially when dealing with quantum mechanics, which is really not intuitive. And so there are two places where the two theories meet. One is black holes, and there is a puzzle there. It's called the information paradox. In principle, you can throw the Encyclopedia Britannica into a black hole. It's a lot of information. And then it will be gone because a black hole carries only three properties or qualities: the mass, the charge, and the spin, according to Einstein. But then when Hawking tried to bring in quantum mechanics to the game, he realized that black holes have a temperature and they radiate. This is called Hawking radiation. And it was sort of anticipated by Jacob Bekenstein before him, and Hawking wanted to prove Bekenstein wrong and then figured this out. And so what it means is black holes eventually evaporate, and they evaporate into radiation that doesn't carry this information according to Hawking's calculation. And then the question is, according to quantum mechanics, information must be preserved. So where did the information go if a black hole is gone? And where is the information that was encoded in the encyclopedia when it went into the black hole? And to that question, we don't have an answer yet. It's one of those puzzles about black holes, and it touches on the interplay between quantum mechanics and gravity. Another important question is, what happened at the beginning of the universe? What happened before the Big Bang? And by the way, on that, I should say, there are some conjectures. It's in principle, if we figure it out, if we have a theory of quantum gravity, it's possible to imagine that we will figure out how to create a universe in the laboratory. By irritating the vacuum, you might create a baby universe. And if we do that, it will offer a solution to what happened before the Big Bang. Perhaps the Big Bang emerged from the laboratory of another civilization. So it's like baby universes are being born out of laboratories, and inside the baby universe, you have a civilization that brings to existence a new baby universe. So just like humans, right? We have babies and they make babies. So in principle, that would solve the problem of why there was a Big Bang and also what happened before the Big Bang. So our umbilical cord is connected to a laboratory of a civilization that produced our universe once it figured out quantum gravity.
It's baby Big Bangs all the way down. It's just big Bangs all the way down.
So if we collect data about how the universe started, we could potentially test theories it can educate us about how to unify quantum mechanics and gravity. If we get any information about what happens near the singularity of a black hole, if we get a sense of, somehow we learn what happens at the that would educate. So there are places where we can search for evidence, but it's very challenging, I should say. And my point is, the string theorists, they decided that they know how to approach the problem, but they don't have a single theory. There is a multitude of theories, and it's not tightly constrained, and they cannot make predictions about black holes or about the beginning of the universe. So at the moment, I say we're at a loss. And the way I feel about this concept of the theory of everything, we should wait until we get enough evidence to guide us. And until then, there are many important problems that we can address. Why bang our head against the wall on a problem for which we have no guidance?
Right. We don't have a good dance partner in terms of evidence. There's not.
Exactly.
I mean, it'd be interesting, just like you said, I mean, the lab is one place to create universes or black holes, but it would be fascinating if there's indeed a black hole in our solar system that you can interact with. So the problem with the origin of the universe is all you can do is collect data about it, right? You can't interact with it.
Well, you can, for example, detect gravitational waves that emerged from that, and there is an effort to do that, and that could potentially tell us something. But it's a challenge, and that's why we're stuck. So I should say, despite what physicists portray, that we live through an exceptional growth in our understanding of the universe, we're actually pretty much stuck, I would say, because we don't know the nature of the dark matter. Most of the matter in the universe, we don't know what it is, and we don't know how the universe started. We don't know what happens in the interior of a black hole.